Welcome back again to Invariable Math. Very excited to continue on this journey, practicing with our derivatives. So we have a new one. We're going to go ahead and get started and jump right in. So we have f of x, and we have that it's a function 2 square roots, one in the numerator, one in the denominator. And this can look messy, but we're going to go ahead and do it. So this is going to be quotient rule. Let's write down a little note over here, just reminding ourselves, how do we deal with quotient rule? So let's see. And I, for one, have to always write this down because I can never remember the order that you have to do things with quotient rule. I always have to figure it out again, anew, every single time. So I know we'll have this in the denominator, which means I know we'll have dB here, so A, so then we have to have B, dA over here. Okay, just a little note for me. That way I can remember how we do this. And I'll do this problem both ways again, like I've done before. I'll do the quotient rule, but then I'll also show the little trick of using the natural logarithm, which I still believe is so much easier. So okay, let's jump right in. So df dx is, so we can see that first, we're going to have to take what's on the denominator and we're going to have to square it. That means the square root itself goes away. Instead of square root x plus 1, we just have x plus 1. Now we got to deal with this on top, which winds up looking a bit messy, and we're going to have to wind up simplifying it, but you'll see. So we're going to have the denominator, which is square root x plus 1, times the derivative of the numerator. So what's the derivative of square root x minus 1? In order to make sure I'm showing every single step, I'm going to actually do that over here. And my poor little puppy is whining again. Don't whine, puppy. So let me do that over here. So ddx of square root x minus 1 is, so this is x minus 1 to the 1/2 power. So what happens is the 1/2 comes out. So let me write that explicitly. We'll have 1/2. Now x minus 1 to the 1/2 power, the exponent, the 1/2, you subtract 1, so it becomes a negative 1/2. That means we're going to have this, the square root x minus 1 in the denominator. Now we have to remember to take the derivative of what's on the inside as well. Well, the derivative of x with respect to x is just 1. So this is our answer for that. So let's come back here. So we have b times the derivative of a, which is the denominator times the derivative of the numerator. And we just figured that out. So that's going to be this. Yeah, this really is going to look messy. So let me rewrite this then. We know this is going to be a fraction. As you'll see, this problem will look messy, but we'll be able to clean things up afterwards. Now we have minus. So we once again need to take the derivative of b, which is the denominator. Let's go ahead and just do that on the side here as well, real quick. You know, this time I'm not going to use the square root symbol, just so it can be clear what we're doing. Okay, it's just exponent rule for differentiating. So the 1/2 comes out, so we have 1/2. Now times, oh, I forgot the 1 there, x plus 1. Now the exponent 1/2, we subtract 1, and it becomes negative 1/2. That means the square root is going to be in the bottom. We have square root x plus 1 in the bottom. Now the derivative of what's on the inside here, ddx of x, is just 1. So here's our derivative. So we're going to have a, which was square root x minus 1, times this. Messy, right? We have to simplify it. We definitely need to make this look nicer. So we'll just deal with this top piece. And basically what we're doing, we're looking for the greatest common denominator. Just like in the old days when we're having to do fractions, same thing. These are just 2 fractions. We're having to subtract these fractions, which means we need a common denominator. So a common denominator we can have would be 2 square root x minus 1 times square root x plus 1. So how would we get that? On this side, we're going to multiply by square root x plus 1 over square root x plus 1. So let me just write that out completely. Okay, now we need to do the same thing with this side. We're going to multiply it by square root x minus 1 over square root x minus 1. Okay, so we're still retaining, so it's as if this is here and this piece is here. Really, we just took each of these and multiplied them by 1 in order to get a greatest common denominator. Now, all of that will be over x plus 1. Let's clean this up even more. So what we're going to get, on the top, we're going to have x plus 1, and we're going to have minus, this is x minus 1, over, now we got to multiply these out. So sometimes it can be a little confusing to look at when multiplying two square root terms together. But what we can do, we can just treat it as if there is no square root symbol. So for example, the way that I'm looking at this is just, what is x plus 1 times x minus 1? We do our FOIL method, front, outer, inner, last. So we get x squared, the two x's will cancel, minus 1. So that's how I'm looking at it. But because of the square roots, after you get your answer, just go back and put a square root over it. And that's what we get. So in the bottom, we're going to have 2 square root x squared minus 1 all over x plus 1. Okay, now we have to clean this up some more. So same thing when dividing fractions. Just like back in the old days when we first learned how to divide fractions, what you're really doing is multiplying by its reciprocal. So let's go ahead and do that. That means x plus 1 really belongs here. And we can cancel these out as well. So x minus x, those cancel. 1 minus a negative 1 is 2. And because we also have 2 down here, they're going to cancel. But let's just write it out. So we have x squared minus 1, x plus 1. And of course the 2's cancel. So our final answer, we have 1 over square root x squared minus 1 times quantity of x plus 1. That's our final answer. I'm going to now clean off the board, and I'll do it again, but with the natural logarithm rule. I think it winds up coming out a little cleaner. I think you don't wind up having this big mess that you have to simplify. But let's see, because that's a good method to get practice with as well. Okay, I've cleaned off the board. We're now ready to do this one again. This time I'll show you the natural logarithm method again. Eventually we're going to get to a point I'm not going to show both methods. I'm only going to do the one that I prefer, which is the natural logarithm method. Just to remind ourselves, how do we take the derivative of a natural logarithm? So let's suppose you have natural log of x. Taking the derivative, you just get dx over x. So let's go ahead and use that method for solving this. So what we do is we take the natural log of both sides. So we're going to have natural log of f. Now the nice thing about using the natural logarithm rule is that division turns into subtraction and multiplication turns into addition. So for example, this just becomes natural log of square root x minus 1. Instead of divide, it becomes minus the natural log of square root x plus 1. Now we go ahead and differentiate both sides. So this side we differentiate with respect to f. So differentiating with respect to f the natural log of f, we're going to get df over f equals, now this is just going to go in the denominator, so square root x minus 1. Now we take the derivative of what's inside here, which just winds up being, we take the derivative of this whole piece, which we remember from last time. I'm not going to redo that. I'm just going to write it out here. Equals that. So we're going to have is this. Okay, now minus, again, this just winds up going in the denominator. And then on top, we have the derivative of this, which is the same as this, just instead of a minus, it's a plus. So we have 1 over 2 square root x plus 1. Now we have the fun part of cleaning all of this up, same as we did before. So this side, we're going to multiply it by square root x minus 1 over, we're going to multiply by square root x plus 1 over square root x plus 1. This side, we're going to multiply by square root x minus 1 over square root x minus 1. That way we can get the same denominators on each side. All over 2 square root x plus 1 square root x minus 1 all over Oh wait, we can't do that yet because these are not the same. So actually, hold on one second. I jumped the gun. I actually need to get these to be the same first before we can proceed. So let's do that. So we want to multiply this by square root x plus 1 over square root x plus 1. So we're going to get, we'll get this. Now minus, now on this side, we want to multiply by square root x minus 1 over square root x minus 1. So we'll have square root x minus 1 over that. Okay, now we've gotten a common denominator in the bottom, which is that. Now we have to work on tackling that top piece. So that's going to be, so we have to do something, we have to do the same thing. We have to multiply this by square root x plus 1 over square root x plus 1 and do the opposite over here. So these get a little bit messy, but that's okay. So that means in the top, we're no longer going to have square root x plus 1. It will just be x plus 1, x minus 1, square root x plus 1. So that's in the bottom there. Now on this side, because we multiplied both top and bottom by square root x minus 1, this just becomes x minus 1. Now all of that is over this. And remember, we figured this out the previous problem. It just winds up being square root of x squared minus 1. Okay, now we can simplify this down more. So this winds up being that as well. Okay, these cancel. 1 minus a negative 1 is 2 over 2 square root x squared minus 1 over square root x squared minus 1. Why is this not looking right? Okay, we're back. We're going to keep on going. This was really starting to feel like it was heading in the wrong direction. Just wasn't sitting well with me, so I kind of just took a bit of time and just re-looked through everything that I had done so far, and I didn't want to waste camera time with you guys just staring at me while I'm standing here going over everything again in my head. So I had paused the video, and we're just going to keep on going. Okay, so let's go ahead and do this. So we have 2 over 2, they're going to cancel. And this is going to be 1 over x squared minus 1. So what is all of this? This is df over f. So actually, let me come down here. And I'm going to rewrite that. So df over f one little detail that I admit now I forgot is there would be a dx here, because after taking all of these derivatives, you should always remember to write the dx. I didn't do that. I've gotten in such a habit of just doing it this way with the natural logarithm. I didn't write dx, but technically there would be a dx over here. So now, what we can do is divide by dx, multiply by f. So we would have df over dx is f times 1 over this. So what is f? We have to go back and look. It's this square root over this square root. So what we get is square root x minus 1 over square root x plus 1 times 1 over quantity x squared minus 1. Now we can clean that up some more. And let's see, how do we want to clean this up? Well, you know, books tend to not like square roots in the denominator. But in this case, it wouldn't be a big deal. But what we can do, let's see, I'm trying to remember how exactly to get the specific answer the way that the book likes the answer to be, because they have their specific way that they have everything written. So I believe the way that the book does it is we're going to multiply by square root x plus 1 over square root x plus 1. So let me just write that out explicitly. So I try to really solve these problems that way the answer winds up coming out exactly the same as the way the book has it printed, even though in reality, an answer can take many forms and still be correct. But I want to make sure it looks exactly the way that the book has it. So what we're going to have, multiply these out, and we're going to get square root x squared minus 1 over x plus 1 times x squared minus 1. And now notice what happens here. This is going to cancel partially. So we're going to have 1 over, whoops, why did I do a second line there? I don't know why I did that. X plus 1 times square root x squared minus 1. So we got the same answer doing it this way versus doing the quotient rule. You pick which one is your favorite. I really prefer the natural logarithm method. Okay, we're going to move on to the next problem. I'm going to clean off the board first. All right, we are ready for our next problem. Believe it or not, I actually already went through and solved all of this, had it nicely broken out, and then I turned around to my laptop and realized I never hit start record. So I get to do this one all over again. Yay me, so much fun. So this one is product rule. And here again is our formula for following product rule. So let's go ahead and start. So first we're going to take the derivative of this one while holding this term as a constant. So let's go ahead and do that. So we have x squared plus 3 raised to the 4th power times the derivative of this. And this piece is going to be exponent rule. So the 3 comes out. We have what's inside the parentheses, but with the exponent lowered. Now we multiply by the derivative of what's inside the parentheses, which is just 6x squared. Because inside here, this little piece, we have exponent rule again. So with derivatives, you start seeing layers. You have product rule, but then nested inside of that is exponent rule, and nested inside of that is another exponent rule. But this is how we get good practice. Okay, now, plus, this time we're going to hold this piece as a constant. So 2x cubed minus 5 to the 3rd times the derivative of this term. And this is, again, exponent rule. So the 4 comes out. We have x squared plus 3. This exponent gets lowered, and we have the derivative of what's inside, which is just 2x. Okay? Now we can't leave it like this. We have to multiply this through and try to find a cleaner looking answer. So let's go ahead and do that. Let me come down. All right, we have 3 times 6x squared, which gives us 18x squared. X squared plus 3 to the 4th, 2x cubed minus 5 squared. Now plus, we have 8x times these two terms, 2x cubed minus 5 cubed, and x squared plus 3 to the 3rd. Now, me personally, I believe this is a perfectly fine answer, but we want to make it look the way the answer shows in the book. I want to show you how the book gets that. So let's go ahead and do that. We're redecorating. So what the book did, it took this final answer, but then it factored some things out. So we can see this piece and this piece can be factored out of either side, and that's what the book did. So let me come down here and I'll rewrite it that way. So we would have 18x squared. Let's go ahead and take these two parts out first. So we have 2x cubed minus 5, and that's squared, times x squared plus 3 cubed. So if we have that on this side, what's left over is an x squared plus 3 term. So we have x squared plus 3. Now we move over to this side. So we have 8x. If we do the same thing, we factor out this piece and this piece. And I'm quickly running out of room, but that's okay. And we have left over one of these terms, the 2x cubed minus 5. So we now have this term, we have these terms, and the book factored them over. So we have dy dx equals, let's see, the 2x cubed minus 5 term, the x squared plus 3 term, and that's going to be times these two pieces, which is 18x squared times x squared plus 3, plus these pieces, 8x, 2x cubed minus 5. Then, let's go ahead and figure this out. I'm just going to write it above, that way I can save some space on my board. So we have 18x to the 4th. We have 48x squared. We have 16x to the 4th. And then we have minus 40x. So what this is 34x to the 4th plus 48x squared minus 40x. And then the book just can't leave well enough alone. It factored out another piece. Hi, puppy. It factored out 2x from this quadratic here. So what we finally get, to make sure our answer matches what we have in the book, is we have this. So what's left here, because it factors out a 2x, so we divide each of these by 2x, so we get 17x cubed plus 24x minus 20. And that is the answer from the book. All right, we'll go ahead and do another problem. Okay, next problem. We have quotient rule, and here's our formula that we follow for quotient rule, just to remind us of what order we do everything in. This I'm not going to show both methods. I'm not going to show the natural logarithm method because I don't want this video to go too long. So let's go ahead and start ds dt. So first off, we're going to have whatever is in the denominator squared. So we're going to have 3 minus t squared downstairs. Now we take the denominator 3 minus t squared, times the derivative of the numerator, which is 2t. Now minus the numerator, which is t squared plus 2, times the derivative of the denominator, which is negative 2t. Let's go ahead and distribute these 2t terms. So we get 6t minus 2t cubed plus 2t cubed, so those are going to cancel, plus 4t. Cancel, cancel. And it's all over 3 minus t squared squared. So we get our final answer, ds dt, is 10t over 3 minus t squared squared. All right, let me clean this off, and we will move on to the next problem. All right, we're going to go ahead and do our penultimate problem. We'll do this one, and then we'll do one more, and then we'll finish up this video for today. So here we have a combination, once again, like what we're seeing a lot of now. We have both exponent rule, and then we also have within that, we have quotient rule. So here's our little note for quotient rule. So let's go ahead. So we're going to have dy dx. First, we're going to take care of the exponent rule. It's going to equal 4 times this, 2x cubed plus 1, and then the exponent gets lowered by 1. Now, we multiply this times the derivative of what's inside here. So that's going to be d dx times this fraction, which means we need to use quotient rule. So let's go ahead and just work on this piece, and then we're going to put it all together. So let me come down here and rewrite this. So following our protocol, we're going to take the denominator and just square it. Now we do the denominator times the derivative of the numerator. So we have the derivative of the numerator, x squared minus 1. The derivative of that is 2x. Now times this, which is 2x cubed plus 1. Now minus the derivative of the bottom times the top, which gives us 6x squared times x squared minus 1. Let's go ahead and multiply this through. So 2x distributed between these two terms, we get 4x to the 4th plus 2x. Now minus the 6x squared distributed through. So we're going to get negative 6x to the 4th plus 6x squared, and then over our little square root piece here, which I'm not going to bother writing because it's right there. Okay, let's clean that up again, and then remembering that we're going to need to multiply it by this. So let's go ahead and do that. So dy dx is going to equal, let's do the 4 times x squared minus 1 cubed. Now I know we're going to have all of this, but first let's take care of our denominator. So since this is cubed, this whole quantity is cubed, it means this top part is cubed and the bottom part is cubed. So we're going to have this bottom piece cubed, but then that's going to be multiplied by this, which is that same piece squared, which would make it a 5th, but we'll write that in our final answer. We'll worry about it then. Okay, so we have this now multiplied by this piece, which we can now simplify. Oh, whoops. And I didn't do that. I was just blindly copying. Okay, so we're going to have negative 2x to the fourth plus 6x squared plus 2x. And then the book also factors out a 2x from each of these terms. And we're going to rewrite this too. That way the minus comes last, because it looks a little funny when you have a quadratic and the first term is a negative. So we're going to rewrite that as well. So we're going to factor out the 2x, which gives us 8x times this parenthesis quantity. Now we factor the 2x out of each piece, which gives us from here a 1. From here, it gives us a 3x. And from here, it gives us a negative x cubed over this to the 5th power. Okay. And that is our final answer for this one. I'll clean off the board and we'll move on to our final problem for today. Okay, this is our last problem for this video, and this is a good one. We're ending on a good note because we're ending with getting practice with chain rule. And then when we come back in the next video, we're going to do some more chain rule practice, and then we'll also practice taking double derivatives, so taking second derivative of functions. So let's remind ourselves of chain rule. Chain rule says that if y, so for this particular problem, if y is a function of u, which it is, and then u is a function of x, if we want to take the derivative of y with respect to x, we have to do two pieces. First, we got to take the derivative with respect to u, and then find du dx. And you can even think of it as that these two cancel, and you wind up getting just dy dx in the end. So let's go ahead and do that. First, let's find dy du, and this is going to be quotient rule. So we're going to have u plus 1 squared in the bottom. And then for the top, I just need to think for a moment because I always mix them up. We're going to have u plus 1 times the derivative of the top piece with respect to u, which is just going to be 1. Okay. Now minus the top times the derivative with respect to u of the bottom, which is just also going to be 1. The u's cancel. 1 minus a negative 1 is 2. So this is what we get for our first piece. dy du is 2 over u plus 1 squared. Now we need to find du dx. So u is square root of x. So du dx is finding d dx of square root x, which winds up being 1 over 2, and the square root of x moves to the bottom. Okay, so we found this, we found this. Now we need to multiply those two together in order to get dy dx. So we're going to get that dy dx equals 2 over, we're going to have 2 square root x u plus 1 squared. The 2's cancel. And remember, since we're finding this derivative with respect to x, we want to have x's in our answer, not u's. So what is u? U is square root of x. So we're just going to have 1 over square root of x times quantity square root x plus 1 squared. That's a nice warm-up for chain rule. When we come back in the next video, we're going to do more chain rule practice, and we're also going to practice taking second derivatives of functions. All right, that's it for today. I will see you then.